All right, so here's the second part of section 11.2. We talked about simplifying radicals in the first part. The second part is about what can we do with them once they're simplified. And we're going to focus on just 3 of the 4 operations because adding, subtracting, and multiplying are probably the easiest ones for us to do. I first want to call your attention to our adding and subtracting rules. And really, we're just going to be talking about combining like terms. So that if I had 4x plus 5x, I don't think any of you would question the fact that that answer is in fact 9x. Because you just add them up. The cool part is that radicals, once they're simplified, are just variables. So I'll say it one more time, and then I will put it up there for you. Radicals, once simplified, are just like variables. So if we're looking at a problem like 4 root 3 plus 5 root 3, we need to go ahead and say root 3. Yep, that's as simplified as it can get. That's a prime number under a radical, so I don't have anything else I can simplify. And root 3 and root 3 are the same, so we can consider them to be the same variable. So it's the same as doing 4x plus 5x. So in this case, we end up with 9, and the variable, instead of being a letter, is a radical, square root 3. When we look at this next example, 4 root 3 plus 5 root 2, 4 root 3 plus 5 root 2, notice here that those variables are different. It's like having 4x plus 5y, because they're not the same radical. So I can't combine like terms. And when I can't combine like terms, I just write it as a sum. So 4 root 3 plus 5 root 2 is as simplified as it gets. This last problem may look like a problem where we have 4 root 3 plus 5 root 2, but the square root of 12 is not simplified. So we actually need to think off to the side here, and we need to take that 5 root 12 and we need to simplify it. So 12 is, let's see, that's 5 on the outside, and on the inside we have 4 times 3. The square root of 4 is 2. So we have 5 times 2 on the outside, and that square root of 3 was not a perfect square. So this is really a 10 root 3. So when I look at this problem, I'm actually looking at 4 root 3 plus 10 root 3. Those are like variables or like terms, so they can be combined. 4 root 3 plus 10 root 3 is 14 root 3. So that big phrase there, and I know it probably sounded silly when I said it or when I typed it, once simplified is an important phrase. You have to make sure that they're simplified. So, do the next one. Actually, I think you could probably handle the first, the third, and the fourth problem. On this fifth problem, you're going to need to be careful with a distribute the negative, right? Because I have a quantity minus a quantity. So we need to distribute the negative before we combine like terms. I think you'll be good on all 4 of those. Give them a try. As I started working, I decided that maybe I did want to work through a couple of these with you. And I wanted to make sure that in that second problem, as you went through, that I gave you the note that you should always put the constant term in front of the radical term. So make sure that you've done that this answer should be 3 plus 9 times the square root of 3. Now let's work through this third problem together. The square root is 75. Well, 75 is the square root of 25 times 3. So that's going to give us a 5 root 3. Or you could do a factor tree just like we did in the last section, plus 3 times the square root of, well, 27 is 9 times 3. So we have a 3 already out there. The square root of 9 is 3, and we get a 3 stuck underneath the radical. So we actually are looking at 5 root 3 plus 9 root 3. So my answer should be 14 root 3. 6 doesn't have any perfect squares, so 5 root 6 is going to stay. 24 does have perfect squares stuck inside. I'm going to do one where we use a factor tree here. So 24. And hopefully this is one of those ones that eventually you'll just have memorized. You won't have to do a factor tree ever. 2, 6, 2, and 3. And there's already a pair of 3s out there. So we have 5 root 6 is already there, minus 3 times 2. So this 3 is a pair already out there, and this 2 make a 6 on the outside. And on the inside, we have 2 times 3. That would be a 6 as well. Now let's do the 150 the same way. Again, you could use any of those methods that we've talked about for finding and simplifying that radical. 5 times 30. Only prime numbers on the outside, so 5 times 6, which is 2 times 3. There's nothing already out there, right? There's a 1, so we can do plus a pair of 5s and the square root of 6. So now I can combine like terms. I get negative 1 root 6 plus 5, so 4 root 6 on that problem. That's what I've got for you with adding and subtracting. The next video will have multiplying on it.